In this video, I'll work out with you problem 39 from page 136 in your textbook. In this problem, we're asked to find the derivative of the function f of x equals 5x squared plus 1 using the definition of derivative. We're going to end up showing that the derivative is a new function, f prime of x equals 10x. To do this, we'll start with 2 points close together on the graph. The first point is going to be at x, so that point is going to be x, and then for its y value we can just write the function 5x squared plus 1. The second point is going to be just a little to the right, but still pretty close together. We will call this point at x plus h. So its point is going to be x plus h, and then to write the y value, we have to plug that x plus h in for the variable. It's a composition of functions problem like what you did in section 1.8 of the textbook. On the next page, we're going to use the slope formula to write the slope of the secant line that connects those 2 points. So writing the slope of the secant line, we're going to take one of the y values minus the other y value. So I'll start with the longer y value and subtract the other y value, but I'll use parentheses here so that I do the subtraction correctly. And then in the denominator, the first x value is x plus h, and then we subtract this other x value, which is just x. So now, we'll use algebra to simplify this. On the top, if you multiply out x plus h squared, you'll get x squared plus 2xh plus h squared, and then we have the plus 1. And then continuing to distribute that negative sign through, we'll have minus 5x squared minus 1. In the denominator, we could go ahead and add up the x and the minus x to get 0. So we'll just be left with h. Now, with more simplifying, I'll multiply the 5 through and we get 5x squared plus 10xh plus 5h squared plus 1 minus 5x squared minus 1 all over h. And now the fun begins. We can add things up to 0. So 5x squared and minus 5x squared add up to 0, and plus 1 and minus 1 add up to 0. On the next page, we'll simplify this a little bit more. From the previous page, we have the slope of the secant line equals 10xh plus 5h squared all over h. I like to factor the top so that I know for sure that I'm going to cancel correctly. So we can factor out an h from this part, and we can also factor out an h from this part. So that leaves us with an h parentheses 10x plus 5h all over h. And now we can do our cancellation correctly, canceling the h on the top and the bottom, so that the slope of our secant line is 10x plus 5h. Now we have to think about those 2 points coming close together, meaning that that little number h is going to approach 0, and that means that in our formula for the slope, the 5h will also approach 0, so that 10x plus 5h will approach just 10x. That means that the slope of the tangent line is 10x for any value of x on the graph. Because we found the slope of the tangent line for any point on the graph, we have proved that the derivative function is 10